This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
Hello, listeners, to another episode of Software Engineering Radio. I'm here with Dr. Axel Rauschmayer. Welcome to the show.
Thank you.
So Dr. Axel Rauschmayer has a PhD in computer science from the Ludwig Maximilian University of Munich. He teaches JavaScript for a company called ECMAScript. He has 2 books out there. One is Speaking JavaScript, which is about ECMAScript 5, and he has the new published Exploring ECMAScript 6 book. He's a frequent speaker and blogger, and everyone around here is very happy to have him here. And he organizes the Munich Java user group. And yeah, we are currently sitting here during the JavaScript Conf Europe in Berlin. And therefore, I wanted to ask him a couple of things about JavaScript and especially about the upcoming ECMAScript 6 standards. Before we go into the show, I would like to let you know we really look into the feedback you give us. So if you write a comment, if you write an email to team@se-radio.net, or if you tweet at SE Radio, go to our Facebook or Google Plus pages, which is Software Engineering Radio. Just let us know what you think of this show, of Software Engineering Radio in general. That's all very interesting to us. We had already a show on Node.js, which is show 230. Which you might also find interesting. But nowadays we want to go a little bit into the language itself, which is kind of behind Node.js. So Axel, could you just start by giving me a 3-minute overview of what JavaScript is?
Right. So JavaScript is interesting because it has kind of an ambivalent nature. On one hand, syntactically, so the way it looks is very much like Java, but the way it behaves is quite different. So the semantics is more like a scripting language. So when it comes to the behavior, it's very dynamic and very flexible, which actually makes it a lot of, or at least for me, it makes it a lot of, and a lot of other people, makes it a lot of fun to work with. It has the syntax is surprisingly flexible. So it's quite astonishing that, for example, right now modules and inheritance libraries are done within the language. And that is something that syntactically I don't think you could do in Java, at least maybe now, but initially you certainly couldn't.
So what you can't do in Java is you say, you cannot redefine how inheritance works in Java. You can just do the Java way of inheritance. And in JavaScript, you can do multiple ways of inheritance.
Absolutely. And I think Java just now got lambdas, so stuff like that. So all of that gives you a tool set in JavaScript where you're very flexible. And well, yeah, as you said, you can even manipulate stuff like inheritance and so on and are very flexible there too. And it is an interesting mix of functional programming and OOP.
Okay. I'm reading a quote from your first book, which is like right in the beginning. Due to its prevalence on the web and other factors, JavaScript has become hard to avoid. That's an interesting statement on the beginning of a JavaScript book. Hard to avoid. So it didn't feel like you came into JavaScript willingly.
It's not the most loved language. It's not the most elegant language either. I personally, and it doesn't have a standout feature per se. But the standout feature of JavaScript is how useful it is, basically. And you have other languages, Lisp, that are like whose syntax is just awesome, or Smalltalk that is syntactically very interesting as well. And you have Erlang and that has that does well when it comes to distributed computing. So with JavaScript, it's kind of like the standout feature is that it's there in the web browser. But over the years, the standout feature now is how useful it is, because there's so much stuff you can do with it. You can do shell scripting via Node.js, web apps. You can even write, basically native apps for Windows 10 and so on. So it's just become very useful now.
So is it that you said, okay, I anyway have to work with JavaScript, so I can better start loving it?
Yeah, in German there's a saying where you say the appetite comes with the eating, like with eating.
Yeah.
And with JavaScript, once Ajax was out, it was quite clear that somewhere you had to program JavaScript. And afterwards, it became clear that you could use JavaScript on the server as well. So you could use a single language. And then it just became a language, as I wrote in the book, that you couldn't avoid anymore. And then why not embrace it if you can't avoid it? But the more you use it, the more fun it is actually. And it is complemented by databases that are that supported natively via JSON. So it's really become fun.
Okay. Maybe before we dive deeper into the language itself, let's talk a little bit about how JavaScript came about. So it was created in 1995, if I remember correctly.
Yeah, May 1995. Yes.
Yeah. And
in 10 days.
So how was it created? In 10 days?
Yeah. So I think it was kind of clear that there was going to be some kind of a scripting language in the browser. And the original idea was that Java was going to be the main programming language in the browser in which you wrote the big components. And then what they wanted to have additionally is a glue language to connect the components. And
the big components were the Java applets at that point in time.
Yes, but I think it was going like the long-term plan was to do more and to have like really basically program whole apps just with Java beyond just applets, I think.
Okay.
And JavaScript was going to be the glue language, gluing everything together. And there was discussion about using something else, even more like PHP-like, I think. So Brandon Eich was under a lot of pressure because he felt obliged to do better than some of the other proposals that were around. So he had to do it fairly quickly, and it took him 10 days. And I think the main challenge was to integrate it with the DOM API, which was C++, and because there's a lot of bugs, so he had to work around a lot of bugs.
Okay. Is it? I've also heard that he wanted to create something more like Lisp, and then he was told no, it needs to look like Java, so he made it like Lisp with a Java syntax.
Yeah, I think the initial sales pitch was come to us, and you get to implement Scheme. That's the urban legend, and yeah, in the end, it had to look like Java because there was a lot of momentum at the time behind Java, and they had, I think, a marketing deal with Sun as well, and Netscape at the time. So he kind of syntactically moved in the direction of Java, but there were other influences as well. So Self was a very big influence when it came to the OOP part of JavaScript, but the way that functions and closures are handled is very reminiscent of Scheme.
Mm-hmm. How did the JavaScript language develop? It was in the beginning just in the Netscape Navigator, which is the predecessor of what we today have as Firefox.
Absolutely, yes.
What about the other browsers? What about the time since?
So initially it was Netscape Navigator in November 1995. I think Microsoft afterwards, they started to implement it too and even copied the bugs. And then Netscape was kind of worried of Microsoft running away with JavaScript. So they then wanted to standardize it to make sure that they didn't lose control to Microsoft. And ECMAScript 1, that was ratified in June 1997.
So ECMAScript it's like a standardization organization?
Yes. So the problem is that JavaScript is a trademark, and only Mozilla and originally Netscape, only they have a license to use it, apart from Oracle that owns the trademark. And so when it comes to standardizing JavaScript, even though the language is JavaScript, everybody calls it JavaScript, the standard didn't have the option, couldn't use the word JavaScript. So they tried to find something else. The standards organization is ECMA, so they called it ECMAScript. And the original thought was that the name was so ugly, but that it didn't matter because it was going to be replaced soon anyway.
Yeah. So they started with standardizing ECMAScript 1.
Mm-hmm. That was in 1997.
Yeah. And today we are talking about ECMAScript 6. Can you walk us through the version history?
Yes. So the ECMAScript 1 happened in June 1997, and that was relatively basic. Initially, there wasn't even exception handling.
Mm-hmm.
That's why JavaScript fails silently quite often.
Yeah. So that was the standardization of the 10-day language, kind of.
Basically,
yeah.
Yes.
Okay. In 10 days, I wouldn't do exception handling either.
So they added that later on. ECMAScript 2, I think, was just a few minor edits, didn't add much. So I'm doing this from memory now.
Yeah.
ECMAScript 3 is basically the language that we know now, or is still very similar to right now. The language everyone is familiar with is ECMAScript 5. ECMAScript 3 is very similar. And I think ECMAScript 3 is when they introduced exception handling and a lot of the other stuff. So that one is still pretty dominant and pretty, still has a strong presence. Then they went all out with regard to features, and that was ECMAScript 4, but that was abandoned because the different vendors just couldn't agree, and it was, in hindsight, it just did too many things.
Yeah. I remember I programmed in ActionScript for some time, and this was actually ECMAScript 4 implementation without ever being a standard, right?
Yeah. Yeah.
It's probably a good idea they never took it further.
A ton of features.
Yeah.
So
and
some nice ones.
Static compilation.
They had static typing. I think they had multiple dispatch, even interfaces. Lots of crazy features. It's quite amazing. That was abandoned in 2008, and you could see that for a long time there wasn't that much interest in JavaScript. In 2005, that's when Ajax happened.
Mm-hmm.
And it took a few years to really percolate, to really become visible. But the date of 2008, when it was really, when ECMAScript 4 was abandoned, kind of shows you that JavaScript became relevant again, and that people really, really cared at that point in time. And then they kind of split it into two versions because they had two camps within the committee that evolves JavaScript. The one camp just wanted to keep things simple, and the other camp wanted to have a lot of new features or make it more powerful. And ECMAScript 5 is kind of the vision of the camp that wanted to do like a tiny step forward.
Mm-hmm.
And the compromise was that the faction that wanted to have more features, that they agreed to not be as excessive feature-wise.
Mm-hmm.
On the other hand, the faction that wanted to have like a smaller step, they agreed to adding significant new features.
Okay. So, but that was all in ECMAScript 5. So
ECMAScript 5 was a minor upgrade to ECMAScript 3.
Yeah.
and cleaned it up, added a few like support for JSON.
Yeah.
So that was the minor step forward, the stuff that could be done relatively quickly, and that's the present day JavaScript basically.
Yeah. And the feature-rich new stuff comes with ECMAScript 6. So ECMAScript
later.
Yeah. So the 5 was a cleanup. Let's do a few things. Use strict was probably one of them.
Yes.
Which
strict
says
mode. Yes.
I want to turn on strict checking, so I can't do the very crazy stuff in JavaScript, which
Absolutely.
is usually creating bugs. And 6 is the new features we're going to talk about.
And you get warnings more quickly. That's a nice feature about like you can make properties read only, but in ECMAScript 3 and in like non-strict mode, sloppy mode, you fail silently.
Oh.
And if you turn on strict mode, you get an exception.
Yeah. So when I listened you talking, you mentioned a couple of times the word Ajax, which I guess most of the people are familiar with. But why is this simple, I can make an HTTP request from JavaScript, such a gigantic step for the JavaScript ecosystem? Why did it make a language nobody liked to a language nobody can avoid?
It's about how you write web apps. And if you look at the traditional approach to programming web apps, there was like my first web app was CGI based. So Common Gateway Interface. That was how you did it traditionally. It was all very static. And if you wanted the app to process input and to show output, it would always have to be a new page that comes from the server. So all the processing happened on the server, and you always had to submit a form. Then the server would do something and send back the output as HTML. And that was very static. And with Ajax, all of a sudden, things became more dynamic, and you could run something in the browser that looked like a desktop application. And the first time I came in contact with an Ajax web app was Google Maps. And at the time that it looked like magic, and in many ways it still is, because you can just zoom around, you can just scroll around in the map, you can zoom in, you can zoom out. And that's a totally different class of app that now you can run on the web, which is amazing.
Yeah. It's interesting because it, as I understand it, the feature was longer in the language, and then it was discovered at some point, right?
Yes, it's a combination of techniques, and interestingly, it was pioneered by Microsoft. So the two main components are XML HTTP request, which is about making requests in the while you're running as JavaScript on the page. So you can ask for more data from the server while the page is still there. So you don't have to open a new page in order to get data from the server. That's part number one. Part number two is dynamic HTML, that you can manipulate what you currently see on the page and change the data structure that represents the page, and everything updates automatically.
Yeah.
And dynamically.
Yeah. So moving away from the web a little bit and looking into the language, let's talk about some of the language features a little bit more. I think one of the things you mentioned is the object orientation model is a different one, and it comes from Self. What is the object orientation model in there?
So when you look at Java and the basic entities of OOP, then you have classes and you have objects. And the two relationships are the instance of relationship between an object and its class. You have the subclass of relationship between two classes. And the main idea of something that is purely object-based as opposed to class-based is that you only have a single entity, and that's the object, and you only have a singular relationship between entities, and that is the prototype relationship. Interestingly, though, you will eventually introduce some kind of an abstraction, some kind of as soon as you want to have multiple instances of something, you will introduce an abstraction, and then conceptually things are very similar to something class-based. So even though you only have objects and the prototype relationship versus more relationships and two entities, two relationships and two entities in Java, for example, conceptually how you structure everything is then almost the same. You then introduce objects that basically are like classes.
Yeah. Can you visualize that with an example? So what would that look like in business code these days?
Yeah. Let's keep it simple and say a point.
Okay.
And in Java, roughly what you would have is a class that holds the methods and the constructor.
Mm-hmm.
And you would kind of invoke that class via new, and it would produce an instance.
Mm-hmm.
So, and then the instance data, the x coordinate and the y coordinate of the point, that will be stored in the instance, and the instance would point to the class roughly so that you know when it comes to methods how to invoke methods on the instance. And in JavaScript, if you look at if we ignore how you set up the instance, which is a bit more weird in JavaScript, or let's say more complicated, then all you have is you have two objects. So if at the bottom you have the instance, and the instance, and all you have in JavaScript are objects with properties, fields.
Mm-hmm.
So at the bottom, you have the instance that has two properties, x and y, and the object at the bottom points to its prototype that is situated above it. Well, that's how you would draw it on paper. Mm-hmm. And the prototype has the methods.
Yeah.
And it's just another object, and that other object also has properties, and in these properties, that's where you store the methods that work, the methods of point.
Mm-hmm.
And the prototype kind of above the instance, that's basically the class in Java.
Mm-hmm. So when I understand it correctly, is the difference is kind of in Java, you just inherit structure, you don't inherit state, you just inherit the methods and the public fields, but not the value of the fields, neither public nor private. In JavaScript, you inherit potentially both?
So there's always a separation of concerns.
Mm-hmm.
You always have two parts. You have and that's what the two have in common, and I'll get to what's Java specific later. So the basic point is there's a separation of concerns, and the instance has the instance specific data, and the class or the prototype object in JavaScript that has the data that is shared between all the instances.
Mm-hmm.
And the methods are the same, and that's shared data between all the instances, and the X and Y that is specific for each instance. What Java has additionally is type information and so on. You're right, and that is something that most JavaScript engines infer the type information.
So what is the use for such a prototypal inheritance system?
It's simpler a bit.
Could you explain why it's simpler, or what is easier
and
to
it's
do?
not, well, as I said before, and it's not drastically different from when it comes to how you structure things. You end up with something very similar. All you have is just so one advantage is you can't start with an instance right away. So you don't have, the singleton pattern is kind of a workaround in Java around the fact that sometimes you just want a single instance. You don't want to have to create a class for that. So that is an advantage of prototype-based object-oriented languages, that you start with an object, you play with the object, and then you introduce abstractions as you go along.
Mm-hmm.
So it's a bit more constructive, a bit more explorative, and it's a tiny bit conceptually simpler because all there is objects.
Yeah.
There are no classes. There is no subclassing.
Okay. JavaScript is also a functional programming language. How can I see that?
So one thing is that if you return something from Java, from a method, let's say an instance of an inner class or something, you have the connection to the surrounding variables, but you have to make all of those final. Otherwise it doesn't work. And with JavaScript, you have more flexibility. So the connection stays live and you can use those to store state that changes. So there you have more flexibility. And that enables you to, that allows you to do stuff like currying and so much more easily.
Yeah, I think currying was part of the Haskell episode, which we had very long ago. I don't know the number by heart, but you can look it up if you want to know more. What is so nice about JavaScript as function, or is it nice to be a functional language for JavaScript?
So for me, the main thing is to just have top level. I'm comparing to Java because that's what I'm like the language apart from JavaScript I'm most familiar with. So I've also programmed a lot of Scheme, and it's compared to Scheme, it's nice to have objects. I like that. Even though you can add an object system to Scheme, it's not as built in. Compared to Java, I enjoy having functions at the top level, but that's actually, I think Java is more of an outlier because if you look at C++ and most other OOP languages that do have top level functions. So having programmed Java for quite a long time, I loved having top level functions in JavaScript. Apart from that, I always try, and some of the array methods that are very functional. So you have map, you have filter, and these are just awesome.
Yeah.
But in general, I try to keep the functional programming stuff simple because you can do a lot of very clever things with functional programming. But I find that if you're too clever, then things are harder to understand later on. So if I revisit code that I have written, even with stuff that's not as exotic like reduce, even if I revisit code that uses reduce later on, it always takes me a while to figure out what I was thinking when I wrote the code. So I try to keep it simple, but stuff like map and filter and so on, these are just brilliant.
Yeah. And a map function is functional because you have a function on an array.
Yeah.
It's called map, and you pass it a function and it applies the function to all of its elements, which is pretty convenient.
Kind of there's a lot of definitions for what functional programming actually is, but one key ingredient is always higher order functions, passing functions to functions as a parameter.
Yeah. All right.
As parameters.
Another property of JavaScript, and in my opinion, one which makes it so simple, is that it's single-threaded. So you cannot create a new thread. What does that mean in a day-to-day business? What is the restrictions, and what are the workarounds, or what are the things that come out of that?
Yes. So interestingly, the simplicity of JavaScript in that area is now a virtue. And when it came to picking a language for Node.js, JavaScript was chosen because it didn't have as much capabilities yet, and it didn't have a big runtime library, so it didn't come with baggage.
Mm-hmm.
And Node.js is fascinating because it is very much multi-threaded, or so there's a lot of parallelism there, concurrency. It's just that you have a single thread that feeds tasks to something that is multi-threaded. So that is fascinating. And right now in the browser you have web workers, so you can do multi-threading if you want to. The key thing is that the TC39, the committee that evolves JavaScript, they want to avoid introducing locks and things to JavaScript that makes it difficult, that lets you write code that is prone to deadlocks and stuff. So they're still in the process, and the ideas are evolving. There will definitely be more multi-threading in the future of JavaScript, and there already is with web workers. And with web workers now, there is a new feature that is called blocking array buffers, if I remember correctly.
Blocking array buffers.
Yeah. And that was introduced for ASM.js to make it easier to compile C++ code to JavaScript.
Yeah. ASM.js is?
ASM.js is, I finished the array buffer thing first, and then we get to ASM.js. And that allows you to block. Right now, you don't block, and that lets you avoid deadlocks. And so a technique that JavaScript uses often is callbacks. So there's a queue, a kind of processed by the event loops, by the so-called event loop in the browser that is a single thread. And in the queue, there's code to process. And whenever something happens, for example, on click, then that is put into the queue, and the queue is kind of processed one task, little piece of code at a time. And with callbacks, the browser can be multi-threaded in the background. And as soon as a result is there, there's no blocking, but instead you put the invocation of the callback, you put that into the queue, and once the other stuff in front of it has been processed, the callback is invoked, and then it can go on dealing with the results from the computation that happened in the background.
Yeah, so it's basically you give the on-click handler a function and say, whenever you get a click event, please execute that code. And therefore, your platform around you can be multi-threaded, but you don't write multi-threaded code. So you get away with the simple single-threaded code.
Simple model.
And the platform is doing all the hard threading work for you.
Exactly. And you use a queue, so it's really easy to figure out, and as a model, it's really simple.
So, ASM.js, just short, what is it?
ASM.js is, so after a while, people figured out that there's certain patterns that you can use in JavaScript that result in really fast code. And if you use these patterns, you can compile C++ to JavaScript, and you get, with newer versions of Firefox, you get, I think, 70% of native speed, which is pretty amazing.
Yeah.
And what that is basically a bit like bytecode, but expressed as JavaScript. And right now, a more recent development is called WebAssembly, and that puts this kind of stuff, doesn't store it as JavaScript source code anymore, but as a binary format. But the structure is still a syntax tree. It's still a tree, and that will give the web a binary format in the long term. But it still sits on top of the JavaScript engine infrastructure and profits from the optimizations and from the cleverness of that engine. And because it sits on top of of current engines, it's relatively easy to implement as opposed to starting from scratch.
Okay. Maybe to segue slowly into the ECMAScript 6 and what it is all about. I often hear the phrase, and I might have been guilty of saying it myself back in the past, that JavaScript is no real language. What makes that feeling, and does ECMAScript 6 anything to change that?
I think it's just been very unorthodox, JavaScript. But what you have to do is you have to take some time to really get acquainted with the language. And then if you use a certain kind of like clever dynamic coding style and some techniques that are idiomatic, that take into consideration the nature of JavaScript, then you can get a lot of work done. And then programming JavaScript has always been a lot of fun. And it got more fun with all the support by all the surrounding technologies. The more it got supported, the more fun it was, and the more capable the browser became, the more other technologies connected. Like I previously mentioned, some of the NoSQL databases.
Yeah.
A few pieces were missing. I think the main piece were modules.
Mm-hmm.
But those were added within the language quite cleverly. And you have two competing standards. You have Common JS that's originally was used on the server more, and then you have AMD that is originated in the browser and is asynchronous, and Common JS is synchronous.
So AMD, if I remember it correctly, you always have to do one extra function per module you include. So you nest the
module is a function call basically. With yes.
Yeah, because you need to wait for something, and the only way to wait, or not really to wait because it's single threaded, but to like make sure you get the resources, is this callback mechanism.
Yes, that is part of the reason. The other part is that it works without eval.
Yeah.
So you can, with Node.js or Common JS modules, what you do is, if you transpile it to something else, because out of the box the syntax doesn't work. So you have to wrap something around it. You have to use eval. Doesn't. And with AMD, you can't just execute the file. You don't have to manipulate the source code. You can't just execute the file and it works immediately.
And so modules get standardized with ECMAScript 6?
Yeah. So now there's a built-in, modules are built in, which is great. And the main advantage of that is it's not that they bring something to the language that wasn't there before, because Common JS and AMD, they work quite nicely. But a big advantage is that, performance will get better. It's easier to statically analyze source code because the structure is more static, less dynamic. So tools will profit. But all those are, they're nice, but they're not like radically better. But the main advantage is that the community, there's now a single standard for modules, and that'll be great.
Yeah. And it's if I understand it correctly, it's again that the syntax is put out there, but the implementations like V8 with Node.js or the Chrome browser or Firefox will have different ways of serving you that module. Is that correct?
Yeah, you have two parts, basically. You have the syntax, and that one is done. That one is standardized now. And on the other hand, you have a programmatic loader API where you can configure what happens when a module is loaded and how it is loaded, how module IDs are resolved, that kind of thing. And that is work in progress. That is still being worked on. And that is separate from the ECMAScript 6 specification. That's a separate standard.
What are some other new features of ECMAScript 6 would you like to mention?
Yeah. So if you look at ES6 features, there are 3 broad categories. Category 1 is there is better syntax for existing features.
Mm-hmm.
And 2 examples are classes, which, well, inheritance was there beforehand, so that didn't add anything significant. But again, standardization matters, and IDEs profit from having a single standard for doing inheritance, because then IDEs have an easier time of analyzing source code.
So how does it change from before? Before you had a constructor function, and you could call new on a function, which was always a bit weird.
Yes.
How is it looking now?
Classes are syntactic sugar for constructor functions.
Okay.
With built-in support for subclassing.
Mm-hmm. Okay, but in the end, the subclass will still be prototypal inheritance. So even if you define a class, what you're really doing is a constructor function, and you're defining a prototype.
Yeah, absolutely. Yeah. So not that much changes with classes, and they're only classes by name, not by nature.
Okay.
And if you do a type of a class, the result is function, which is kind of funny. So that's category 1 is better syntax for existing features. Category 2 is a better standard library. So they add a few things. A nice one is maps and sets, because at the moment you're always abusing objects as maps, which is which I don't like. Because you run into problems. There's like you have to be careful with the key __ proto _ because that triggers triggers like special behavior. You have to be careful with inheritance and so on. So if you're careful, you can use them as maps from strings to arbitrary values, but it's better to and you can't use methods anymore, because those may be entries in the object. So it's and with maps you get a real data structure that's dedicated to that, and then lets you use arbitrary keys, and you have methods, and so
no longer just strings as keys.
Exactly, arbitrary, even the objects, anything now. So that's really nice. It's really not too much to ask for. JavaScript is really, really late when it comes to that. Then you have promises for asynchronous programming, new methods for strings and arrays. So
can you explain promises? Because I'm not sure everyone knows about them.
Promises are a nicer way of doing callbacks, basically. So the thing is, if you move from a normal synchronous function to something asynchronous, the signature changes, and you have an additional 1 or possibly 2 additional parameters that are the callbacks that for delivering the results or for receiving the results. And with promise, it's a bit like the signature becomes simpler, because the signature doesn't change, and you return something from the function, and that is a placeholder for the result.
Yeah.
And afterwards, you can have a method chain. So the method is then to receive the result, and that has a callback.
Okay.
So and what you then get, like, error handling improves because apart from then, there's always you can also catch errors. And then you have a single way of error handling. It's not like if you do it with callbacks, you may get an exception somewhere.
Yeah.
Or you may get a failure, and then the failure callback is called, or an error code is handed to you.
Yeah.
And with promises, there's a single way of error handling, and it's always the error callback.
Yeah. So rather than calling a function and giving it a callback, or more callbacks to do error handling, I call the function, get a result, and in there I can supply the callbacks who do this stuff.
Exactly.
Yeah.
So it's not radically different from callbacks.
Yeah.
It's a bit nicer, and you can chain stuff. But it's not like if you code callbacks properly, then you can already get pretty close to what promises are doing. And so, well, as I said, error handling is an advantage. And it's a standard.
Yeah.
Right now, there's so many conventions. XML, HTTP request works differently from some of the Node.js APIs and so on. And slowly everybody is moving in the direction of promises. So there'll be a single mechanism.
Yeah. It sounds a little bit similar to futures in Java.
Absolutely.
Yeah.
That's where it comes from. Absolutely.
Okay. So you said we have maps and sets, we have promises, and we have new methods on string.
So the third category is completely new features.
Mm-hmm.
And with the additions to the standard library, there's also a shim that you can use, and then you can use those in ECMAScript 5 just as well.
Yeah. So shim is a small library.
It's backporting something basically from a future version or from the current version to an older version. And that gives you maps and gives you stuff like for strings starts with and that kind of like tiny little improvements.
Yeah.
The completely new features are like the main ones I think are generators, proxies, and Weakmaps.
Yeah. Yeah, then let's go through all of them. So what is a generator?
Yeah, wow. Okay, that's a very complex feature. It does a lot of things at the same time.
Yeah.
I think the construct, it corresponds to the traditional construct it corresponds to is our coroutines.
Mm-hmm.
And apart from like it's a feature that JavaScript or ECMAScript 6 borrowed from Python. So generators are come from Python, and there's a lot of good literature written by Python people on generators. So what it is a piece of code, and that piece of code can say yield at any time, at which point it's paused and kind of goes to sleep, and then you can wake it up later on and it continues its computation.
Yeah. What's a task you would do with something like that?
So there are two interesting things. One is it helps with implementing iterators.
Mm-hmm.
So if you, an iterator basically is, well, often it's implemented as a method, but it's a function that you call repeatedly and that produces one element at a time for a data structure. And then lets you treat a lot of data structures the same way.
Mm-hmm.
Trees or lists or what have you. So if you want to enumerate the elements of, for example, of a tree, one element at a time, manually, it's a bit painful. If the function is called repeatedly, it has to remember where it is within the tree in order to keep going correctly. If, on the other hand, if you do it via recursion, it's simple to like if you use recursion to visit all the nodes of a tree, that's nice. And with a generator, what you can do is you visit the nodes of the tree via recursion, and then every time you are at a node, you say yield.
And the recursion stops here, and the next time it comes
pauses
back.
And after that it comes back. And with the yield, you can also return a result. You pause, you produce a result, and then later you're woken up and you continue your work. You visit the other nodes.
Okay, yeah, that sounds interesting.
That's nice. The other thing is for processing asynchronous data.
Mm.
So you can, if you trigger an asynchronous computation, say a download of a file, then you can write all of the code like you can write synchronous code, but you can't just pause until the result is done, and then you're woken up and you continue your computation.
Mm-hmm.
And then you don't have to deal with callbacks and anything. You just say, okay, pause now, do your thing, download in the background, and please wake me up once the computation is done. And then you can just assign, you can just say, let text equals download file.
So you kind of do an asynchronous program without having it look asynchronously.
Exactly.
Ah, yeah. Okay.
And you do it in a way, this kind of asynchronous computation, it becomes blocking again. Because the generator goes to sleep, and obviously you have to wrap code around it, and you have to insert the yield and everything. So it's not, there is some trickery going on, but conceptually what these asynchronous calls have always been is a blocking call.
Mm-hmm.
And the callback was just the synchronous code that came afterwards put into the function, and then it becomes in functional programming that's called a continuation.
Yeah.
And that already gives you a clue what it does.
Yeah. Okay. Yeah. It's a bit like Go routines in Go, right?
Absolutely.
Yeah.
Yes.
So proxy. What is a proxy?
Proxies are objects where you can intercept the operations that are performed on the object. So it's metaprogramming.
Yeah. So it is basically, so I guess most of the listeners know the proxy design pattern where you have an object before another object, and is that just the one?
Loosely related.
Yeah.
There are, if I remember correctly, do you mean like proxy design pattern, or do you mean the interface metaprogramming thing in Java?
No, actually the design pattern in the Gov book, where you say you have an object with X like a local resource, and then you have the backend thing.
It's very loosely related.
Yeah.
Obviously, because the proxy is always like something, a placeholder.
Yeah.
But it's more like, I think the feature is called proxy as well in Java. It's a bit more of an obscure feature where you can have an interface.
Mm-hmm.
And then you have a handler, and the handler is informed whenever a method is invoked on the interface, and you get told that method A has been invoked with these parameters.
Is it like method mything in Ruby? The method which is called when the method is not.
That's very much like it. Yeah.
So the method which is called when the method is not on the object. Then
it's that's a small talk. Inspired feature. So and it goes beyond that, because it's, even if you do I think instance of check-in things, like there's several operations. If you just read a property, if you set a property, so a lot of operations that you perform on an object are, and you can listen to those via something that is a bit like an event handler.
Mm-hmm.
And that allows you, for all kinds of metaprogramming stuff. So you could implement data access objects.
Mm-hmm.
You could, I think, remote method invocation in Java is implemented by like the interface proxy thing. And that's another application, remoting. And I think it also helps with implementing the DOM in JavaScript, because the DOM has some strange things that you can't do in the language. And with proxies, you get more flexibility with regard to what you can do in the language.
Mm-hmm. Okay. And Weakmap is essentially a map which which is not holding objects for garbage collection.
Yeah. So you can put things into the Weakmap, and it doesn't prevent the keys from being garbage collected.
Mm-hmm. Okay. So it generators, proxies, and Weakmaps are the new features. All of them have a theme around making the language a little bit more like meta-programmy, I would say. And that
because those you can't easily do right now. Because
I have a quote from someone, and I haven't. Probably more people have said it. That's why I don't have an author for it. But it says JavaScript is the new bytecode. So JavaScript is the language we don't write, we compile to. Is that is that serving to this trend, or do you think it's more for the language itself?
So the another way of putting it is JavaScript is the assembly language of the web.
Yeah.
That is about to change with WebAssembly because there were a few features were added to ECMAScript 6, and one is integer multiplication that help with compiling C and C++ to JavaScript. And those are not, like in normal JavaScript, they're not good for much. So, and back then, JavaScript still was the assembly language of the web. But now with WebAssembly, there's a split. And you have something that is still hosted on top of the JavaScript engine, but there you can add features that are not interesting to JavaScript as a language now. And the generators, proxies, and Weakmaps are more features that just elevate the language itself. So that is not something that is, maybe generators for should you want to compile something that has coroutines. Possibly. But those were really created very much with the language in mind and not this cross-compilation thing.
All right. So we're running late on time. So before we move on, maybe one last or two last questions. One is, this episode will be out in early 2016, probably. Will ECMAScript 6 be available to everyone, or is it still in beta?
Early 2006. So there are two ways to actually use ECMAScript 6. The one is natively in browsers, and there's the ES6 compatibility table by Kangax. We can look up what's available where. And I suspect in early 2016, it could be that the first engines support all of it. But the other way that is very popular right now is to transpile, to compile from ECMAScript 6 to ECMAScript 5. And the most popular technologies is Babel. Babel is used there quite a lot.
Babel is just so you feed it your ECMAScript 6 code and you get ECMAScript 5 out of it.
Yes, and it works really nicely.
Yeah. You have been working with it for a while?
I have, yeah. Okay. It's quite amazing how quick adoption has been of ECMAScript 6 and of the new features. And most people, there was some skepsis initially, but most people that after they start to work with the new features, the feedback I get is really very positive.
Do you think it has influenced the development of the standards that the transpiler were so early available?
Yeah, and that'll get even stronger.
Yeah.
Because there's now a new. It's always been a bit like that, but there's now a new process in place for the upcoming versions, and a strict requirement is any feature that is proposed has to have, I think, 2 implementations.
Okay.
It has to be implemented, and in order to try it out, and that obviously that's great because it's not. It's being tried out in the wild and in real world scenarios, and
you're not likely to do something like Java generics, which all of the engineers involved today consider a bad idea.
Yeah.
Okay. What do you think will have the most influence on the JavaScript community from the new features?
So I always have so my standard answer here is I think the 2 most boring features are going to be the most important ones. And that will be classes and modules. And a lot of JavaScript people do not like classes, I think, for legitimate reasons. But they're not radically different from what we're doing right now with constructor functions. and they will help with tooling a lot. And same thing with modules. We already have modules right now, but to have a single standard will be great. So again, like it's standardization.
But you take freedom away from the people who've been doing it by hand all the time.
Yeah.
Okay. Is there some last thing you want to say?
No, I'm fine.
Okay. So then I would ask you, so I've mentioned the two books. Speaking JavaScript is about ECMAScript 5 and Exploring ECMAScript 6 is about ECMAScript 6.
Yeah.
Obviously. Anything else you would like to promote?
So what may be interesting to listeners is that the complete contents of both books are available for free online. So you can just go to the websites and the links will be published on the web page for the
show
podcast.
Notes,
And you can just go to the websites and read the whole book if you want to.
Although you will probably like it.
I love people who buy them for sure. Yeah.
Anything else you would like to promote?
Well, maybe my blog, so duality.com. So what I like about blogging is that it's the interaction I have with the readers, and if you look at the comments from my blog post, the quality is always very high, and I learn a lot through my readers because they give comments, and it's very useful and very interesting discussions.
Yeah. And you also run ECMAScript trainings.
Yes.
So
ECMANauten, it's called, and we hold trainings in, basically anywhere, but then it's a matter of paying travel costs.
Yeah.
So.
All right. So you mentioned your blog. You're on Twitter, and I guess people can contact you over this.
Exactly. Yeah.
All right. Then I would come to an end. For the listeners, we will have show notes. So every link mentioned, I will put them in the show notes. Thank you very much, Axel, for being on the show. It was very interesting.
Thanks for having me.
Insightful. Please give also Software Engineering Radio some feedback and let us know what you like, because we will learn from it as well. So write a comment on the website or on iTunes. Write an email to team@se-radio.net. Tweet at SE Radio or on Facebook and Google+. We are Software Engineering Radio. With that, I'm Johannes from Software Engineering Radio. Thanks. Until the next time, and goodbye.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter @SE Radio, or search for the Software Engineering Radio group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.